Okay, welcome to day 2 of Credit 9. Um, you're going to watch that video on the characteristics of quadratic curves and then identify some of those here. So I'll go and do this one for you. So you label the coordinates of the vertex. The vertex is that extreme point that it reaches. And then also state whether it's a maximum or a minimum. So this is the highest it gets, so it's a maximum. And we're also drawing a dotted line for the axis of symmetry. So if you were to fold that, what would make it the same on both sides of that fold line? That's the line of symmetry. And then it says write an equation for the axis of symmetry. That would be x is equal to -3. That's the vertical line going through -3. Okay, so jumping down here, we're looking at a table of values for f of x equals x squared. And then we want to compare these values. So where's the axis of symmetry here? It looks like through 0, right? So it's going to have the same axis of symmetry. So it's going to be something like that. And it's going to be a little bit lower. So 0, -7. So it's down here. Something like that. Okay. But go ahead and graph those points and you'll see what you come up with. Okay, the next question says, what is the equation for g of x? So the equation for g of x is going to be something like ax squared plus bx plus c. So if it has the same sort of growth as this one, we won't have any b. And it's just going to be, so let's see, it goes from 7 to -3, so it's going up by 4 when it goes up 2. So it looks like it has the same a, which is 1. So y is equal to x squared plus c. And then when x is equal to 0, we get our y value should be -7. So that means c is -7. So anytime you could just look at what is the 0 value, that's going to be your c value. So y is equal to x squared plus -7 or -7. You could write either way. So that's the equation for g of x is x squared minus 7. And what way did it move compared to f of x? So you could say it probably slid down. And then you can do these other ones in a similar fashion. Okay, and check your axis of symmetry. So the axis of symmetry here you see is not at 0 anymore. So it probably shifted towards -1. If you really run into trouble, you could go to Algebra and graph these points and do the equation. Just say g of x equals fit poly. Use this command, and then you have to have a list of points like we've done before. So do fit poly list 1, and it'll give you the function g of x in GeoGebra. So that's one way you could do it if you can't put it together yourself. To find a value that, to find an equation that actually is true for all these values. Okay. And more of similar things. So you're gonna, what is the vertex of this? So you're going to put in the point that you find is the vertex, and it's going to be at that axis of symmetry. So what are the x-intercepts? So that's like where is it crossing the x-axis? So when does it go to 0? When is g of x equal to 0? So it's somewhere between -3 and -4 here, and also between these values, right? Between -7 and -6. Okay. So here you're going to use GeoGebra and graph these three on the same graph. and label the different functions. Do a little sketch here of what you see in GeoGebra. Okay, so you get to this point, and we have our general form. This is called the vertex form, where the vertex of the parabola is at h comma k. So it's shifting by h in the x direction, and k, it's getting lifted by k in the y direction. So that the equation of the line of symmetry is going to be your x value of the vertex. X is equal to it, right? How do you tell if the parabola is up or down? So look at the a value. Does it matter if it's positive or negative? And how do you identify that dilation? So how is a affecting it? It's multiplying it. So look at that. Okay, lining up quadratics. So go ahead and put this in GeoGebra and see what we come up with. Like, what is the line of symmetry? Where do you find the vertex to be? Where are the x-intercepts? So where is it crossing? So where is the parabola crossing the x-axis? Those are x-intercepts. What's the y-intercept? Vertex. So it might not. It probably isn't centered on this. It's probably something like that. So the vertex over here, the y-intercept, x-intercepts, and so on. Okay. So based on these examples, how can you use the quadratic function in factored form to 1. Find the line of symmetry of the parabola, find the vertex of the parabola, find the x-intercepts of the parabola, and find the y-intercept of the parabola. So looking at these factored forms and what you came up with, what conjecture can you make about these different points? Okay, and then answer those questions in your math notebook. And that's it for day 2.